So now we're going to look at base 16. This is the last number base we're going to look at, hexadecimal, used a lot by computers. Obviously base 16s, we'd really want digits to represent 0 to 15 in there. But of course 10, 11, 12, 13, 14 and 15 are two-digit numbers, so we can't use those as we discussed in base 12. So what we do is we use 0 to 9 in the normal way, and then we use A to represent 10, B to represent 11, C to represent 12, D to represent 13, E to represent 14, and finally F to represent 15. So these are the, if you like, digits that we use when we're doing hexadecimal. So we could have a number such as 7, 3, 4, 1, 2 point, let's say A, B, 5. And then we could look to convert that. Of course, we're working with powers of 12 as discussed for other number bases. So if we were converting into decimal or base 10, we would do 7 lots of 6, 5, 5, 3, 6. And then we'd have 3 lots of 4, 0, 9, 6. We'd have 4 lots of 256. We'd have a 16 and 2 ones. That's the whole number part dealt with. 472082. But we'd also need to deal with the decimal part, or should I say the part this side, since it's not really decimal. So we have got A, which we know is representing 10. So we would have 10 over 16. And then B represents 11, so that would be 11 over 256. And then we've just got 5, which of course represents itself. So we've got 5 over 4096. And that gives us, as a decimal, this number here. Let's just do 3 decimal places, 0.669. And so we can say that 73412.AB5 in base 16 is 472082.669 in base 10, correct to 3 decimal places.